joint probability distribution. We're looking at a situation where we have more than one random variable. So you have discrete random variables x and y. We'll start off with an example, go through some of the notation. We have an urn that contains 5 green, 4 red, and 7 orange marbles. 2 marbles are selected at random without replacement. X is the number of green, and Y is the number of red. We want to find the joint probability mass function of X and Y. And the notation here is the probability of the pair ij, which represents x equals I, and y equals j. And so in general, that means both of those have to occur. X has to be equal to I, and y has to equal to j. All right, so let's take a look at some of the situations here. So what would P of 0, 1 represent? That would mean x is 0 and y is 1. So we have the number of green is 0 and the number of red is 1. Now, we're not directly keeping track, but by default, there's going to have to be a second selection, so that second one will have to be 1 orange. So the probability of that happening, we're going to take 0 green, 5 choose 0, 1 red, which is 4 choose 1, and then 1 has to be orange, that's 7 choose 1, divided by the total possibilities here, which we have a total of 16 marbles, and we're choosing 2. So the denominator is 16, choose 2. 5 choose 0 is 1. 4 choose 1 is 4. 7 choose 1 is 7. So 4 times 7 is 28. Downstairs, we have 16 choose 2, which is 120. So it's 28 out of 120 probability of getting no green, 1 red. All right, let's say 0, 0, which would mean that we have 0 green, 0 red. There's only one way to do those, so we can skip that over. So both of the two that are selected have to come from the orange set. So that's going to be 7 choose 2 over the grand total of 120. 7 choose 2 is 21. So that's 21 out of 120. All right, 1, 0, 1 green, no red, which means by default it's going to have to be 1 green and 1 orange. So that's 5 times 7, 35 over the total. 2, 0, that's 2 green and nothing else. No red, no orange. So all 2 come from the green. It's 5 choose 2 on top. 1, 1 is 1 green and 1 red. So it's 5 times 4 is 20. 0, 2 means both of them are red. 4 choose 2. And that should exhaust all the cases here. Should always double check that the total does add up to 1 whole. In this case, 120 over 120. So we'll make a chart here for this. We have X in the row and Y in the column. Each of those could be 0, 1, 2. So the probability of both of them being 0 was 21 out of 120. 0, 0, 1 was 28 out of 120 up top there. 0, 2 down at the bottom, that was 6 out of 120. Let's see, 1, 0. X is 1, Y is 0. 1, 0 is 35 out of 120. 1, 1 is 20 out of 120. Now, 1, 2 is impossible because that would lead to a total of 3 selections, only selecting 2. So that's impossible. That's 0. Then we come down to the last row here. We have 2 green. It has to be 0 red. That was 10 out of 120. We can't have either of these other possibilities. The total cannot go above 2, so both of those are 0. So this is our joint probability mass function in chart format. As always, the total has to add up to 1, and none of the probabilities can be negative. Now, if we restrict to just a row or column, we get the probability for each variable separately, and that's referred to as the marginal probability. So the probability that x is 0, we look at just the top row, and we add those values up, 21, 28, and 6 out of 120. That's 55 out of 120. Probability that x is 1, we add up everything in that row, 35 plus 20, 55 out of 120. X is 2 for 2 green, it's 10 out of 120. Notice this last column here adds up to 120 out of 120. Now we work with red, so we fix the column here. So for y to be 0, for 0 red, we add up everything in that column, which is 66 out of 120. For 1 red, it's 28 plus 20 is 48 out of 120. And for 2 red, it's 6 out of 120. And again, if you add those up, you will get 1 whole. So the marginal PMF is given by the individual column sum, probability that y is equal to a fixed value. So adding the columns, or restricting to the rows, which gives us the marginal PMF for x. So the probability that x is 0, denoted P sub x of 0, corresponds to the row where x is 0. It's 55 out of 120. Same thing for x equals 1. X equals 2, it was 10 out of 120. And then we move to the y's, and we get 0. Probability that y is 0 is 66 out of 120, that y is 1 is 48, and y is 2 is 6. Not really required to reduce here. I think it's in this particular setup, I think it's nicer to have a common denominator. Joint cumulative CDF of x and y, that's a running total. So that would be f of a, b, meaning that we want the probability that x is a or lower, x is less than or equal to a, y is less than or equal to b. Now the marginal CDF, we're working one at a time. So the marginal CDF of x would be the probability x is less than or equal to a, and y less than infinity, y would be free. Which is the same as taking the probability as the limit as b goes to infinity, where y has to be less than b. All right, second example, find the probability mass function of 2 fair dice rolled. Now, we got to be careful here. X is the maximum value and y is the sum. So we want to be careful. These ordered pairs here are not representing the 2 rolls. The first component is the maximum. The second component is the sum. The maximum value could be from 1 through 6, allowing for ties. And the sum is 2 through 12. So this notation 1, 2, probability of 1, 2, x is 1, y equals 2, means the maximum is 1, the sum is 2. That could only happen if they're both 1. So there's one way to do that, 1 out of 36 probability. Now, we cannot have 1, 3, 1, 4, 1, 5, or 1, 6. If the maximum is 1, then both values have to be 1, and we cannot get a sum higher than 2. So all of the rest of those are impossible. Then we move down to the 2 now. Again, if the maximum is 2, sum has to be higher. There's no zeros, no negatives. Sum has to be higher. So maximum value of 2, sum is 3. It's going to be 2, 1 or 1, 2. There's 2 ways to do that. 2, 4 could only happen if both values are 2. Would have to be double 2, which is 1 way out of 36. 2, 5 is not possible because in order to get 2, 5, we would need a value higher than 2, but 2 in the first slot is the maximum value. So 2, 5, and 2, 6 are impossible. Notice here, for if the maximum is 3, then the smallest the sum could be is 4. Could be 4, 5, or 6. Probabilities are 2 out of 36, 2 out of 36, 1 out of 36. Maximum is 4. We could have 5, 6, 7, 8. And again, we see a pattern here with these probabilities. So I'll leave this to you to try to see if you can get some type of closed form for this PMF, taking into account the restrictions here on the values. We see that in most of these situations here, we're getting out 1 out of 36. So we're getting out 0 or 2 out of 36. So see if you could summarize that in a chart form. All right, part B of this question. Now, this time we're going to make X the min and Y the max. So it's the min and max of the face values. So if X is the minimum and Y is the maximum, then the only way out was 1, 1. That's 1 out of 36. If X is 1 and Y is 2, then we could have had 1, 2, or 2, 1. So there's 2 ways to do that. If the max and min are the same, it had to be a double. So the probability of 2, 2 is 1 out of 36. Same thing with 3, 3. If the max and min are the same, it means the rolls were the same. So all those values there where the X and Y are the same, it's 1 out of 36. I didn't fill in everything here, but we do have a summary chart coming. Let's see. Again, 1, 4. There's 2 ways for that to happen. 1, 4, 4, 1. Now, 2, 4 could only happen. I'm sorry. 2, 4 is going to be the same thing. 2, 4, 4, 2. 3, 4, the same thing. You can get 3, 4, or 4, 3. So we see a pattern here that when the values are different, then the probability is 2 out of 36. When they're the same, it's 1 out of 36. We cannot have X larger than Y. X is the minimum, Y is the maximum. So we cannot have X bigger. So we cannot have something like 2, 1 or 3, 1. So summarizing here, if the min and max are the same, we had to roll a double. It's only one way to do that, 1 out of 36. If the max is larger than the min, the values are different. You could reverse the order. There's 2 ways out of 36 for that. X cannot be greater than Y. That's impossible. Probability 0. The minimum value cannot be larger than the maximum. Now, the restriction here on X and Y, while technically they both could range from 1 to 6, we know that the maximum is greater than or equal to the minimum. So we could write it in this form. 1 is less than or equal to X, which is less than or equal to Y, where Y is topped out at a possible 6. All right, that concludes the video here for lesson 19 on joint PMF. Please feel free to email or post in the discussion board if you have any questions.